The nature of light is the real beauty of science and the universe. How it behaves, the thing it exists into two different elements, and in particular, how its rays makes us see the real beauty of everything. Imagine the world without the presence of light. It would be vivid, dark, and you would see nothing. However, we wouldn't be able to embrace its existence without the things that makes us view the light. Our eye is a complicated system performing several functions as it manipulates light to make us visualize everything. Life is more beautiful with your eyes, so better take care of them properly. We also have devices and gadgets who makes use of the light to magnify things, which we call as optical devices. Cameras, telescopes, magnifying glasses, binoculars, eyeglasses, and many more to mention. It is really amazing how these things work like it's magic. But do you know there is only one thing that makes all these things possible? They are lenses. What? Lenses. But why and how? What are lenses? Lenses are basically transparent materials usually made from plastic or glass. But what makes them different from other glass materials? Lenses are not flat surfaces nor opaque. Instead, they contain at least one curved surface. Now, how do they work? Since they are curved, light rays won't expect to go to a straight direction as it passes through them, nor reflect since it's transparent. They work by refraction, bending light rays, changing them directions. They can also be classified into different types, but usually we only know two of them, which are convex and concave lenses. Concave and convex lenses have their distinct differences according to how they shape and how they portray these rays and images.
A microscope allows us to see and view things which are impossible to be seen by our naked eye. It is so powerful, it allowed us to view the world of teeny tiny organisms that we don't see. Perhaps we should give a big thanks to him for his wonderful invention. This human tissue, as an example, allows us to see the cells and nerves and other microorganisms on it. Oh, there is plankton. Going further, this device is also composed of different parts with different functions. You will see the main highlight of it is the objective lens that is responsible for the magnification of the object. Now, I think it would be better to grab your pen and paper as you might ramble along the way.
We have already witnessed the power of convex lenses, the way how they magnify near objects precisely. But for a microscope, one lens isn't enough. A microscope is made of two converging convex lenses. Let's go deeper. First, we should know where our object will be placed, which is right here. And then, the light source located below the diagram, which is right here, that illuminates the object. Now we can start illustrating. The two convex lenses present in the microscope are first, the ocular lenses, or also known as the object lenses, which is closest on the object. The second one, we have the eyepiece, where we look through to view the image.
Keep in mind that the objective lens has a short focal length, usually below 1 cm. The focal length on the eyepiece, however, is also short, but it is slightly bigger. The object is placed outside FO, the focus of the objective lens. Since the object is placed between the 2F' and F', a real, inverted, and a larger image is formed located beyond 2F. This image formed will now serve as the object for the second convex lens, the eyepiece. Basically, now, what would happen is the eyepiece will become a magnifying glass that will look and enlarge the image that is created by the convex lens. However, in order for the eyepiece to act as a magnifying glass, we need to adjust the position of the hollow tube. That will also adjust the focal length and the focus itself. After adjusting, in this case, Image 1 now, or the object of the second lens, is slightly inside the focal point and the eyepiece, between F' and midpoint.
A diagram, we will have this illustration forming a virtual, erect, and magnified image located in front of the lens, which is way beyond here. Looks distance to the diagram shows it. The net magnification of the microscope, whereas the net magnification is the product of the linear magnification of the objective and angular magnification of the eyepiece. This explains us now why and how the object is being magnified, allowing us to see very detailed large images. And here you go. This explains the application of lenses in microscopes. It might look complex because of the different diagrams. The process as a whole is just easy. Again, how optical devices such as these and how they manipulate every object we see is just magical and spectacular. Before your eyes, push yourself in learning and study hard.